Why did the heliocentric model take so long to be accepted? Imagine looking up at the sky and seeing the sun seem to stay still while the stars and planets appear to move around Earth. It's easy to see why early thinkers believed Earth was at the center of everything. For centuries, people believed the universe revolved around Earth because that's what they experienced daily. The sky looks like it moves around us, and ancient philosophers like Aristotle agreed Earth was fixed and unmoving. This idea fit with their physics, which said objects naturally moved toward the universe's center, which was Earth. The heliocentric model, which puts the sun at the center with Earth and other planets orbiting it, was first suggested by Aristarchus of Samos in the 3rd century before the Common Era. But it was hard for many to accept because it challenged what they saw and believed. The idea that Earth rotated daily and moved around the sun sounded strange and even impossible to some. They wondered how objects on Earth could stay put if the planet was moving. Plus, the physics of the time didn't support such motion. Another big obstacle was the lack of observable stellar parallax. If Earth moved around the sun, stars should shift position slightly in the sky. But early astronomers couldn't see this shift with their instruments. To explain this, Nicholas Copernicus suggested that stars were much farther away than anyone thought, making the parallax too tiny to detect. Still, many remained skeptical because the evidence wasn't clear enough. When Copernicus published his model in the 16th century, it was more elegant than the complicated Ptolemaic system. Yet, it still used circular orbits and needed extra circles called epicycles to match observations. This made it just as complex and less accurate than the geocentric model. Plus, the idea went against the religious and philosophical views of the time, which saw Earth as the center of God's creation. Many believed Earth's position was a divine truth, so accepting a sun-centered universe was a big challenge. Later astronomers like Tycho Brahe and Johannes Kepler improved the model. Tycho's precise measurements and Kepler's discovery that planets move in elliptical orbits made the heliocentric system more accurate. Galileo Galilei's telescopic observations, such as seeing moons orbiting Jupiter and Venus showing phases, provided strong evidence that Earth was not the universe's center. These discoveries made it easier for others to accept the heliocentric idea. Culturally, the heliocentric model faced resistance because it questioned humanity's place in the universe. It suggested Earth was just another planet, not the special center of everything. This was uncomfortable for many people and challenged long-held beliefs. Over time, as more evidence accumulated and scientific methods improved, the idea gained acceptance. It became a milestone in science and changed how humans understood the cosmos. So, the reason it took so long for the heliocentric model to be accepted is because it went against everyday experience, lacked direct proof at first, was complicated and imperfect early on, and challenged religious and cultural views. It was only through better observations, improved models, and shifting ideas about the universe that it finally gained recognition.